Hi everyone. The question is the number of integers k for which the equation x cube minus 27x plus k equal to 0 has at least two distinct integer roots is. So here let me just first consider a function fx, let's say x cube minus 27x. Now if you consider this given equation which has left hand side x cube minus 27x plus k compared to the graph of y equal to fx, the graph of this expression would either shift vertically above or vertically below depending on whether k is positive or negative. Very easy to understand. Yeah. So here what's the deal with this? If you see carefully, the function, this function is something like this, where 0 is one of the roots and 3 root 3 and minus 3 root 3 are the other roots. And what about derivatives becoming 0? So you have 3x square minus 27 equal to 0. That means x is equal to minus 3 and plus 3. Yeah. So the graph is not looking symmetrical, but actually it is symmetrical. Let's not redraw it. You can easily understand it on your own. So here f of 3 essentially is what? If you see carefully, it is minus 54, and f of minus 3 is what? 54. So here first of all, at least two distinct integer roots, and also we are interested in the integer value of k. Yeah, for at least two distinct integer roots there should be at least two distinct roots. Yeah, which will be when you shift the graph above by 54 units or below by 54 units. Yeah, because beyond that there wouldn't be even two distinct roots. Yeah, so for two distinct integer roots there should be at least two distinct roots, and for two distinct roots k should be in this interval. It can, since we are talking about integral values of k, it can be minus 54, minus 53, so and so forth up till 53, 54. Yeah, because if it if the graph moves 54 units above, or rather more than 54 units above, there would be exactly one real root only. And similarly, if it moves more than 54 units below, which you can easily see based on what's happening with x cube minus 27x. Now, but k being k can take so many values possibly, so to make cases like this is not a good idea. So you make yet another observation. As you shift above or below, there is one root that will come for sure. I mean, at least one root will be there in this interval minus 3 to plus 3, minus 3 closed to plus 3 closed, isn't it? As you move it above or below, ensuring that there are at least two roots. So there will be at least one root in this interval minus 3 closed to 3 closed. Another thing that you notice, sum of roots is 0. Yeah. So what you have is sum of roots is 0. Now if you have two of these roots, total 3 roots can be there. Two of these roots, if they are integer, the third root would also be integer. Yeah, the third root also integer. So that means, since at least one root will be in this interval minus 3 closed to 3 closed, that one root will surely be an integer. So what all values can that root take? So one value of that root can be minus 3. Yeah, in which case minus 3 would be the repeated root. Why? Because derivative is also becoming 0 here. In fact, in that case I believe k would be, you can see k would be, if minus 3 is the root, k will be minus 54. Check it out. Yeah, because it will shift 54 units below and it will be something like this. Yeah, if minus 3 is the root, it will be definitely a repeated root. Why? Because derivative is becoming 0. Yeah, so if x equal to minus 3 is a root, it will be a repeated root, and since sum of roots is 0, it will be a repeated root, and since sum of roots is 0, x equal to 6 would also satisfy it. And you can check it out, not a big deal. Just try satisfying x equal to minus 3, and I've just now said that k will turn out to be minus 54. You can check it out, satisfy it, and you find the value of k, and then you find the other roots also. You will get this only. So sum of roots 0, so the third root you may say is x equal to 6, and which is acceptable. Why? Because although x equal to minus 3 is repeated root, and what we want is two distinct integer roots, the third root also turns out to be an integer, and hence there are indeed two distinct integer roots. So this is acceptable. Similarly, x equal to 3, if it is a root, it will also be repeated because derivative is again 0 at x equal to 3, and as per sum of roots, the third root will be minus 6. Again, this case is acceptable, two distinct integer roots. And by symmetry, you can check for if you check for x equal to minus 2 and x equal to minus 1, it is similar to checking x equal to 1 and x equal to 2 by symmetry. I hope you are able to see, or you may check it anyway, because I will just be doing for minus 2 and minus 1, and if you are not convinced about the symmetry, you can try on your own for 1 and 2, because if you are shifting such that x equal to minus 2 is a root, my bad, if you are shifting such that x equal to minus 2 is a root, and if you are shifting such that shifting above or below by varying the value of k, such that x equal to 2 is a root, so that means 2 is a root, so you will have what, you will have something like this, and it will be something like this. So there is a sort of, if you see carefully, symmetry involved with respect to the two curves. What happens for x equal to minus 2 being root on negative side happens when x is equal to 2 is a root on positive side. Similarly, as such, and ultimately what we are concerned about is the integral roots. And what about x equal to 0? When x equal to 0 is a root, then fx is essentially or rather k essentially is 0, and we have just now seen the roots will be 3 root t minus 3 root 3. So 0 being a root doesn't give you two distinct integer roots. So only two conditions that I should be exploring further is x equal to, let's say, 1 being root and minus and 2 being root. Similarly, if x equal to minus 1 gets accepted, x equal to 1 you may accept by symmetry. And similar for 2 and minus 2. So let me just consider, let's say, x equal to minus 2. If x equal to minus 2 is a root, then you have, it will satisfy this equation. So you have minus 8 plus 54 plus k equal to 0. So k turns out to be what? Minus 46. Is it? Just give me a moment. Minus 2 if you put minus 8. So you have k to be minus 46. So you have what? You have x cube minus 27x minus 46 equal to 0. Now here, what about the product of roots? Product of roots is 46. So that means if x equal to minus 2 is a root, the product of other two roots will be what? The product of other two roots is essentially minus 23. And 23 is a prime number, right? So minus plus minus is so here 46 is the product of roots. So but if you see carefully, since we are interested in integer roots, minus 2 is one of the roots, so other root one more should be integer. In fact, both other roots should be integer. We have just now we have concluded it in the beginning. So plus 1 minus 1 don't satisfy this equation anyway. So if 1 doesn't satisfy, that means minus 23 would also not satisfy. If minus 1 doesn't satisfy, then 23 will also not satisfy, because the product of remaining two roots is minus 23. So the point is, there is no and 23 is a prime number. So there is no other integral root if minus 2 is an integral root. And what about minus 1 being integral root? So you get minus 1 plus 27 plus k equal to 0. So essentially the equation would be what? X cube minus 27x minus 26, yeah, minus 26 equal to 0. So again, you may say that product of other two roots will be what? Product of roots is 26. So product of other two roots, since one of the roots is minus 1, would be minus 26. Yeah, yep. So here minus 1 is definitely not a repeated root. Check it out. So derivative will be what? 3x square minus 27. Minus 1 doesn't satisfy this, that means minus 1 is not a repeated root. And if you see the other possible integral factors of minus 26, 1 doesn't satisfy this equation. Minus 1, anyway we have seen that it is not a repeated root. Minus 1 satisfies, but it doesn't satisfy again. I mean, it is not a repeated root. Yeah. Similarly, you can say what about 13 and or rather than going for 13 or minus 13, plus minus 2 you may check. If you put 2, it doesn't satisfy. If you put minus 2, it doesn't satisfy. So if 2 doesn't satisfy, minus 13 would not. If minus 2 doesn't satisfy, 13 would not. Why? Because product of roots is minus 26. Yeah. So that means even in this case, you don't get distinct integer roots. Similarly, you may check, for your conviction, for 1 and 2 being the roots. Yeah. You not get two distinct real roots in them also. Same, just as you haven't got for minus 1 and minus 2. So that means there are just two possibilities. There are two values of k which are effectively 54 and minus 54, which is when minus 3, 3 are the repeated roots in these two cases, is when you get two distinct integer roots. B is the answer. Thanks for listening.